I bet you didn't know how magical the world of fluids can be. Once upon a time, in the fascinating realm of science, there existed a magical world of fluids. Imagine a scorching summer day, and you leap into a cool, inviting pool. The splash of water is like a refreshing embrace. Or picture yourself blowing bubbles in your milk with a straw, watching them grow and burst with delight. These simple joys are brought to you by the enchanting nature of fluids, making our everyday moments magical. Fluids are everywhere, from the air we breathe to the water we drink. They are the lifeblood of our existence. Without these vital fluids, life on our beautiful planet would cease to exist. What makes fluids so captivating is their ability to flow and morph. Unlike the rigid nature of solids, they gracefully take the shape of their container, a property known as fluidity. This unique trait makes them indispensable in our daily lives and in engineering marvels like dams and machinery. From the cars we drive to the airplanes that soar and the ships that sail, fluids are the unsung heroes of transportation. Even within our bodies, fluids like blood are vital, transporting nutrients and oxygen to keep us alive and thriving. The weather patterns that shape our days are also a dance of fluid dynamics in the atmosphere. So, embark on this journey with us and uncover the secrets of the wonderful world of fluids. Imagine a detective not solving crimes, but unraveling the mysteries of how fluids move and behave. That's fluid mechanics for you. This fascinating branch of physics delves into the secrets of how fluids respond when forces come into play. Picture yourself holding a garden hose, your thumb partially covering the end. The water sprays out with surprising force. That's the magic of fluid mechanics in action. It unravels the why behind such phenomena, and so much more. Engineers harness this knowledge to craft airplanes, ships, pipelines, and even irrigation systems. They strive to make these designs not just efficient but also safe. But the wonders of fluid mechanics aren't reserved for engineers alone. Anyone can dive into this knowledge to see the world through a new lens. So, let's embark on this journey into the captivating realm of fluid mechanics. Imagine a world where everything is static and unchanging. But thankfully, we live in a world of movement and flow. Enter the fascinating realm of fluids, which come in two main types, liquids and gases. Both of these states of matter can flow and change shape, creating a dynamic environment around us. Picture a glass of water or a bottle of juice. These liquids have a set volume but effortlessly change shape to fit their container. Try squeezing them, and you'll find they resist compression, maintaining their volume no matter the pressure. Now, let's turn our attention to gases, the more flexible cousins of liquids. Unlike liquids, gases have no fixed shape or volume. They expand to fill any container they find themselves in. Think of blowing up a balloon. The air inside expands, filling every nook and cranny of the balloon. Both liquids and gases are essential for life, playing crucial roles in our daily existence. We rely on water to quench our thirst and oxygen to fuel our breaths. Understanding the behavior of these fluids unlocks the secrets of our world, making it a more fascinating place to explore. Let's dive into a story. Imagine you're on a thrilling game show, and your challenge is to guess the weight of two mysterious boxes. Before you stand two identical boxes, each the same size and shape. One box is brimming with light, fluffy feathers, while the other is packed to the brim with heavy solid rocks. Now take a moment to ponder. Which box do you think holds more weight? If you guess the box with rocks, you're spot on. The rocks make it significantly heavier. This is because rocks are denser than feathers. Density is the secret ingredient here. Density measures how much mass is packed into a given volume. It's like how tightly things are squeezed together. In the world of fluids, density plays a crucial role. It influences how fluids interact and behave. Take oil and water, for instance. Oil floats on water because it has a lower density, forming a distinct layer on top. Density also explains the magic of hot air balloons. The hot air inside the balloon is less dense than the cooler air outside, causing it to rise majestically. Density impacts many phenomena, like buoyancy and fluid pressure. By grasping the concept of density, we can unravel why some objects float while others sink. It's all about how much mass is crammed into a space. It also sheds light on why different fluids behave in unique ways. Density is a captivating and essential concept in the realm of science. Welcome to Chapter 5, where we dive into the fascinating world of viscosity, also known as the stickiness factor. Imagine you're pouring honey from a jar. Notice how it flows ever so slowly, almost as if it's reluctant to leave the jar. Or think about ketchup. It takes its sweet time to come out of the bottle, doesn't it? That's the magic of viscosity at work. Viscosity is essentially a measure of how much a fluid resists flowing. It's like the fluid's internal friction. Think of it as the stickiness of a fluid. The stickier it is, the higher its viscosity. Thick fluids like honey and syrup have high viscosity, which is why they flow so slowly. On the other hand, thin fluids like water and alcohol have low viscosity, allowing them to flow easily and quickly. Viscosity plays a crucial role in many aspects of our lives and industries. Take motor oil, for instance. It needs just the right viscosity to effectively lubricate engine parts and keep them running smoothly. Or consider paint. Its viscosity determines how easily it can be applied and how smoothly it dries on surfaces. By understanding viscosity, we can choose the right fluids for different tasks and enhance our designs. It's a sticky subject, but an essential one. Chapter 6. Smooth sailing or rough waters. Types of fluid flow. Picture yourself by a tranquil river, where the water glides effortlessly downstream. The scene is serene, the flow is smooth, and everything feels in harmony. Now imagine standing by a wild, untamed river. The water crashes over rocks full of energy and chaos, creating a dramatic and powerful spectacle. These contrasting scenes illustrate two distinct types of fluid flow: the calm, orderly flow and the wild, turbulent rush. Each tells its own story. The smooth flow, like our peaceful river, is all about order. The water moves in straight, predictable paths, creating a sense of calm. Here, water particles glide in parallel layers, barely mixing. This makes the flow stable and easy to predict. Such smooth flow is ideal for pipelines, where it ensures minimal energy loss and efficient operation. On the other hand, turbulent flow, like our wild river, is a dance of chaos. The water swirls unpredictably, creating intricate and dynamic patterns. In this scenario, water particles move erratically, mixing constantly. This makes the flow lively and full of energy. Turbulent flow plays a crucial role in nature, driving weather patterns and ocean currents. Its chaotic nature is essential for these natural phenomena. Understanding the difference between smooth and turbulent flow empowers engineers to design better systems and helps scientists unlock the mysteries of nature. By delving into these flows, we can enhance technology and deepen our knowledge of the world around us. Welcome to Section 7, where we unravel the fascinating story of flight. Have you ever gazed at an airplane soaring through the sky and wondered, how does it stay up there? The secret lies in a magical principle known as Bernoulli's principle. According to this principle, air that moves faster has lower pressure. Imagine blowing over a piece of paper. The paper lifts because the air above it rushes faster, creating a zone of lower pressure. This very principle is what gives airplanes their lift. Airplane wings are ingeniously designed to speed up the air over the top surface. This creates the lift needed to keep the plane aloft. Bernoulli's principle isn't just for planes. It explains many wonders, from the flight of curveballs in baseball to the lift of kites in the wind. Section 8. Real-world wonders. Fluid mechanics in action. Imagine a world where fluid mechanics is the unseen hero. It starts with the water flowing effortlessly through our household pipes and extends to the majestic wind turbines harnessing energy from the breeze. Fluid mechanics is woven into the fabric of our daily lives. Engineers, like modern-day wizards, use it to craft the cars we drive, the airplanes we fly in, and the buildings we live in. They harness its power to make our world work better and safer. In the grand theater of nature, fluid mechanics choreographs the dance of weather patterns and directs the flow of ocean currents. It even helps us foresee natural disasters and safeguard our environment. In our everyday routines, like taking a refreshing shower or brushing our teeth, and even in the kitchen while cooking, fluid mechanics is quietly at work, making life smoother and more efficient. Chapter 9. Keep exploring the flow. We've embarked on a fascinating journey into the world of fluid mechanics. Along the way, we've uncovered the basic properties of fluids and explored the mesmerizing dance between laminar and turbulent flows. We've delved into key principles like Bernoulli's, revealing the secrets behind their behavior. But remember, this is merely the beginning of our adventure. Fluid mechanics is a vast realm, brimming with endless discoveries. From the intricate flow of blood in our veins to the cutting-edge designs of advanced aircraft, the possibilities are boundless. So let your curiosity soar and continue to explore the enchanting world of fluids. Don't forget to subscribe, like, comment, and share to stay updated with our latest explorations.